This part is the smart object rules of our game, including all game logics we used. Here is our human playing level, and we have the robot as our player and the red cube as our minion. And we can see that we have transparent green cubes here. They are our enemies. They are traps that can cause minions death. And we can see here the blue fork. It is the final destination of our minions. And now we can see here our smart object rule clause for the fork is named as go. And then we open the trap prefab. There are cubes, and we can see here from the rigid body properties, we can see the smart object rules class for them are named as enemy. And back to our rules panel, we have two absolute rules here. For the follow one, they were designed for minion movement, and for minion angry, it was a class for inaction between minions and traps, but we are disable them. And first enabled class is activate. They are the class implementing that how player summons the minion and how minions follow a player. And here is the second class named go. In the go part, we have simple flow graph, just call hide function on minions and let the go object know we see one more minion. Here we just output a string to let the player know we sent all minions to our go. Printing win function is defined in entity go's Lua script. And now we open the Lua script. In our Lua script for the go, we define a counter for number of minions saved and a value for number of minions should be saved. And each time we catch a minion, the go will figure out whether if we win or not. And we have some functions for the go, like on reset. And this is the event catch. Here, the catch emoji means catching a minion and increment saved minion counter by 1. And here are some basic rigid body functions. And this is the function for onUpdate for our go. And this is for define a flow graph node. We have some inputs and we have some outputs here. So we have our basic flow graph structure here, and this is the nodes. This is our go node. And we actually tried many other methods to implement our go. We tried to incorporate it with the MPT so that it is a part of players in a function, but it actually requires usage of proximity trigger, which we did not figure out how to use, so we settled on using smart object rule flow graph, and it works really well with the rest of functionalities. And here is the destroy class. It is intentionally misspelled for searching easily. And in this flow graph, it's kind of similar to the Go flow graph, just prints out the minion dies message if a minion die in a trap. We can see here, this is the Go flow graph, and back to our destroy flow graph. We use the same inner function hide to set minion's disappearance in this flow graph. However, the trap is not working in AI player version because we did not successfully incorporate the wait ability of AI so that it can wait in front of a trap, then go through it. The proximity trigger, area trigger just doesn't work somehow, but ideally we could use an area trigger to tell the AI to wait a random time. If that falls, the AI will wait a little longer during the next iteration, so it will eventually pass the trap without losing a minute.